This is an example of how to inverse a function. In particular, we'll look at a quadratic function in two different ways. The first way, a more traditional way, is to write the word inverse to tell the reader I'm about to switch x and y, and I'll do exactly that. I will take the equation, and by definition of an inverse, I'll just switch the location of the x and y's. And now my goal is to get y by itself. I do that by inverse operations, doing everything that's happening to the y in the opposite order and in the opposite sign so that I can get y by itself. It starts with getting rid of this plus 3. I'll take away 3 both sides. I get x minus 3 equals 2 times y minus 1 squared. Next thing is I'll divide by 2. You might ask, how come we didn't do the brackets? I will, but I'm doing inverse operations. I'll do the brackets last. First I'm going to do divide by 2. And so I get y minus 1 squared equals x minus 3 divided by 2. Before I can do this stuff in the brackets, though, I got to do this exponent. What's the opposite of square? Square root. Remember, when we square root, though, it's got to be a plus or minus square root. And it's got to be on this whole fraction, plus or minus square root. On the right-hand side, plus or minus square root cancels the square, and I just get y minus 1. And on the left-hand side, I'm left with plus or minus the square root of x minus 3 all over 2. All that's left to do to get y by itself now is get rid of minus 1, which is easy. Just add 1 both sides. Make sure you add this 1 on the left side, though, outside of the square root sign. And what you're left with is y equals the plus or minus square root of x minus 3, all divided by 2, and outside all of that, plus 1. There's my inverse equation. Let's put a box around it to show the reader we're done. Okay, but if you didn't want to do that way, there's a second way. You could instead list the steps of what's happening here, like transformations. What's happening to x? Well, let's go in order that we see it. First we see subtract 1. Then we see next operation is a square. I'm going from, okay, did the thing inside the brackets. Now let's square. Once we square, we multiply by 2. And at the end, we add 3. So for the inverse, we're going to do the exact same operations, except do them in the opposite order. I'm going to go from the bottom up, and I'm going to change them to be the opposite operation. So I ended with add 3. I'm going to do the opposite thing, subtract. And instead of adding 3, I'm going to subtract 3. Next thing, instead of multiplying by 2, I'm going to divide by 2. Next thing, instead of squaring, I'm going to square root. And I'm going to write down plus or minus so I don't forget, for good communication, to put it. Reverse the add, reverse the multiply, reverse the square, and now reverse subtract 1, add 1. That is, I took these steps and I did them in the opposite order. They went this way. Then I did them backwards here. And every step where it said add, I subtracted. Where it said multiply, divide. Where it said square, I square rooted. Where it said subtract, I added. And now I can write my equation. So, y equals x, take away the 3, then divide that all by 2, then square root it, put a plus or minus, and finally add 1. And notice these two different ways, I still got the exact same equation, which is why both of these methods are equally as good.